In today's Artificial Intelligence and Expert Systems class, we are going to see Unit 1, Chapter 2, that is about problems, problem spaces, and search. So, general problem solving. Whenever to build a AI system, that is, whenever we need to solve a particular problem in artificial intelligence, we want to concentrate on four things. The first thing is to define the problem precisely. The definition of the problem, that is, to give a good representation of the state space, is aptly needed. And second problem is you have to analyze that particular representation, that is a problem. Third one is to isolate and represent the task knowledge that you are needed to solve that particular problem. And fourth one is to choose the best problem solving techniques, and you should apply that technique to that problem to be solved. So these are the four steps: definition, analyzing, third one is representation, and fourth one is choosing the best problem solving technique. So as a first step indicate, definition come across, or it is going to deal only with the state space representation. We have to define the problem as a state space search. So problem solving, you can say it is a process of generating solutions from observed data. You can say a problem as is characterized by a set of goals. Second one, you're going to deal with objects, and you're going to deal with the operations that you're going to deal with the objects. A problem space is an abstract space. A problem space encompasses all valid states that can be generated by the application and it may contain one or more solution. A solution is nothing but it is a combination of operations and objects that you will apply to achieve your goal. And the second one is search. That search refers to a solution in a problem space. And search proceeds with different types of search control strategies like breadth first, depth first search. So these are the two common search strategies that you will apply when defining a problem in your state space search. Next, you're going to see about how you're going to define the problem in the state space search. So that you will come across nearly 6 key elements of problem solving. One is the state. So what is meant by a state? A state is nothing but it is a representation of problem at a given moment. State space is contain all the possible states. Operators, the available action that is being performed. Initial state is the position from which the problem solving is start. Starting position is called as the initial state. And goal state is nothing but it will give you the solution to the problem. And rules, it will describe the actions that are available. So problem that you're going to deal or that you're going to design in AI will use a common term called a state. So what it is a state? It is going to represent a status of the solution at the given step when you're following the technique that you're going to solve a problem. The current situation or the current state of a solution space is called as a state. So the solution of a problem is nothing but a collection of problem states. The problem solving procedure will apply an operator to a state to get to the next state. Then it applies another operator to the resulting state to derive a new state. The process of applying an operator to a state and a subsequent transition to the next state, and this process will continue until a goal state is being achieved. So this method of approaching a problem, you call it as state space approach. So you will always deal with a set of possible states that you will traverse or you will transit from one state to another, and the current state will give you the solution. So this problem can be solved by using the rules in combination with appropriate control strategy that will move from the problem space until you find a solution from the initial state to the goal state. This is specifically called as search. For example, you can take the problem of playing games. Here we are going to solve the problem of chess. When you take a chess game, you can see each position you're going to describe by an 8 by 8 array. And in that initial position is nothing but the game opening position, and the goal position is the position in which the opponent does not have a legal move and his or her king will under attack. This will be your goal position. So you can able to describe your set of legal moves with the form of rules. That is, left side you can say the rules, and the right side you can give the new state. But in general, these legal positions can't be stored in a computer memory since there will be more number of moves. State space is a set of legal positions starting at the initial state, and you will use your set of rules to move from one state to another, and you will attempt the goal state. This figure describes you about the one legal chess move. And the next one is, this is a legal move, this is the rule. But you can think it over, there will be a number of legal moves when you're playing a chess game. It is not possible to write all the rules and it is stored in a computer memory, because it will pose serious difficulties like no person could ever supply a complete set of rules and no program could easily handle all those rules. So these difficulty problems is there, and you can see this chess move can be also represented in another way like this: white pawn, square, which position is being placed and in which it is empty and which rank can be given. If this is the condition, you can apply this pawn to move to the another square. Like this you can write the rule. Either you can store in this form or you can give it this in this representation. That is, when you're playing a chess game, you're giving these rules. So this representation of games will lead to a state space representation, and it is natural for well organized games with some structure. This will follow surely the formal definition of a problem from the initial to target. It means that solution involves using known technique and a systematic search, and this is a quite common method in AI. A state space, it can represent a problem in terms of states and operators that are going to change a state. So a state space always consists of states, operators, initial state and final state.